Hello, everybody. My name is Mark Barrett with Blue Wireless. So today we're going to be talking about the various differences and merits of licensed exempt, or sometimes called unlicensed millimeter wave spectrum, as it relates to a number of commercial applications. Okay, so the first question is what is licensed exempt spectrum? And this is spectrum which is freely available to all users in the market without having to pay any special license fees, typically to the national regulator. In the UK, that would be Ofcom, as an example. So as a very well-known example, Bluetooth and Wi-Fi both use unlicensed spectrum at 2.4 and 5.8 gigahertz. And obviously everybody has Bluetooth and Wi-Fi devices, and they don't need to pay a fee for using that spectrum. So that's what licensed exempt spectrum means. As regards the applicability to millimeter wave, there is a much wider millimeter wave licensed exempt frequency band, which originally was defined as 57 to 64 gigahertz, and has recently been extended from that to 57 to 71 gigahertz. So that means you have, or rather customers have the ability to operate within 14 gigahertz of license exempt spectrum, up to a power level of 40 dBmi, which is 10 watts of transmitter power. And the regulations for operating within those limits are all enshrined in European and, in the case of the US, FCC regulations. So when manufacturers develop and take to market equipment which complies to these regulations, they are obliged to ensure that those regulations are met by going through an independent test and validation process with the type approval test house, which is, for example, is what we have done at Blue Wireless with our millimeter wave equipment. So traditionally, as is well known, mobile communications devices have used specific frequency bands. Originally, for example, 900 megahertz for GSM, and then that moved up to 1.8 gigahertz for DCS 1800 GSM phase 2, and then onwards into 4G frequencies at 2.1, and now we have other frequencies emerging at 3.5. And all these pieces of the frequency band are subdivided up and licensed out by Ofcom on an exclusive basis for use by mobile operators. So that means within that band, only that operator has the right to transmit their own particular service. And the largest difference between license exempt and license free spectrum is that in licensed spectrum, the operator can transmit at much higher power levels from the base stations in order to have a larger coverage area. So there are many other aspects, but that's the biggest significant one, I would say. So in the case of millimeter wave, we transmit at a somewhat low level, around 40 dBmi, as I mentioned before. And one of the other unique attributes of using millimeter wave is the shorter range and line of sight dominated nature of propagation. And that's beneficial for license exempt because it means that the interference levels that are seen by adjacent systems which are operating, let's say, a few kilometers away, are very low. And moreover, we also use active beamforming to really direct the energy toward the receiver and therefore away from other potential devices. And we also have other interference mitigation measures in our equipment to make ourselves more robust toward interference from third parties. And as a consequence, the interference levels that we expect and are sometimes seen, for example, at 2.4 and 5.8 gigahertz, are very low, and therefore should not be a concern for commercial deployments. Well, that's simply because they wish to control all access to that particular piece of the spectrum, and in that regard, they see it as a significant commercial asset to guarantee the service for their customers. But as is also well known, people use Bluetooth and Wi-Fi devices every day without overly being concerned about quality of service, and generally have robust connections. Excepting, of course, there are some corner cases where you need to consider the operation of, for example, Wi-Fi. I'm sure you've seen the circumstance where your neighbour's Wi-Fi can overlap with your Wi-Fi, and therefore you have to move the frequency by hand usually to avoid interference. So there is interference, but it's usually well controlled. And in the case of the mobile operators at lower frequencies, which are comparable to Bluetooth frequencies, they wish to minimize that, and that's why they spend money on licensing pieces of spectrum for their service. Well, there are a few things going on in the 3GPP world, to my understanding, and I'm not as close to that as others are, but from what I've read, the latest release of the 3GPP specification, I think it's release 16, goes up to 40 gigahertz, and in that frequency range, there are licensed bands emerging, for example, at 39 gigahertz and 28 and 26 gigahertz, which are subject to the same licensed rules that I was explaining earlier, where you need to get a license from the regulator to operate in those bands. There is a new working group being created for looking at 3GPP and 5G NR waveforms above 40 gigahertz, including 57 to 71. And that's at a very early stage, and it's probably 2 or 3 years away from coming up with firm proposals which are then ratified and adopted by the industry. But again, the same rules would apply. They would have to work within the same power limits and the same regulations that apply to everybody else who uses the licensed Zenc band. And remember, the licensed Zenc bands don't actually specify the waveform or the protocol that is used by the equipment. As long as equipment abides by the good neighbor rules in terms of transmitter power and a few other relatively simple requirements, then other standards are free to operate in the same band. So that has happened before. So, for example, there was something called ULTE, unlicensed LTE, 4G LTE, which was designed to operate in the, I think it was the 5.8 gigahertz band. So there were some equipments out there which did that before from the 3GPP world. So I think this initiative to look at high frequencies and licenses exempt from 3GPP is a manifestation of that. But as I mentioned, it's several years away from implementation, from what I've read. Okay, so I hope this short video has helped to explain the differences between licensed and license exempt, or unlicensed spectrum, if you prefer. I think I've tried to position license exempt millimeter wave spectrum as being a very good resource to deliver gigabit grade connectivity for private networks, for fixed wireless, and for small cell backhaul. And Blue Wireless is active in all these markets in varying degrees. And if you want to find out more information, please contact us.